Welcome to a lesson with Dr. Powell. Let's take a look at the exact same example that we had, y is equal to square root of x, and let's look at it again a little bit. What if we were to have something like y is equal to 2 times the square root of negative x plus 1, and maybe have a plus 1 out here. Now, let's see how we're going to graph this. Think of the square root symbol as being like this graph here, the original graph. And we're going to move from the square root symbol into the new x. And we're also going to move from the square root symbol outward via operation path up in order. First multiply it by 2 and then add 1 to finally arrive at y. So we're going to have a pathway of how to go from the square root to the y and the x. That pathway computationally right here in the formula itself tells us exactly what's happening to the x and y values on the original graph. Whether we're shifting one way or another, stretching, pulling, reflecting, whatever else we're doing is all right here formulaically. And it has to do with the computational path that we take right from the square root either into the x or ultimately outward from the square root to the y. Well, let's start with the inward one. So the path from the square root in to the x that's embedded in here in a package, negative x plus 1. Let's see what that path is. Well, first from the square root, we hit the whole package, negative x plus 1. What do we have to do to that package? Well, we subtract 1 to it to give us a negative x. Then what do we got to do with that? Well, let's multiply it by negative 1, and that'll give us x. You see this subtract 1 and that multiply by negative 1? That's exactly what's happening to all the x values. All the x values are going down by 1. That means we shift to the left 1. Now notice all the x values now are going to be multiplied by negative 1. What happens then? Well, if you multiply something by a negative and you over here, you get over here. If you multiply something over here by a negative, you get over here. In other words, you reflect across the y-axis. You have to be careful about order. Computationally, this is very specific. First subtract, then multiply. Also, geometrically in the graph, it's very specific. It needs to follow the same steps in the exact same order. Don't swap the order because you might get a different graph, depending on the situation. Okay, so here, let's just see visually what this would look like with the graph. First, doing these basic transformations. So first, we start with our square root function. Now it looks like we're going to shift it 1 unit to the left. Okay. Then it looks like we're going to reflect that across the y-axis. So we end up getting something like this after doing our transformations. Of course, as we do this, it'd be nice to follow where specific points go, and we might do that in a minute. But for now, let's just focus on what's happening here so we kind of get an intuitive sense. So we've just done the x transformations. Now let's look at the y transformations. What's happening there? What's on the pathway from the square root to get to the y? Well, you start on the outside of the square root this time because y is like output. Remember, x is like input, inside, outside. So we start on the outside of the square root. And what's the first thing we do to the square root before we can get to the equal sign that represents the whole thing of the expression? Like, how do we build up this whole expression? Instead of getting down into the x, we try to get up, out to the whole here to get to y. So we take this square root, and what we're doing with it, we're multiplying it by 2. That's the first thing to do. So for our y transformations, the first thing we're doing is we multiply by 2. And what's the next thing we do to get the whole expression? We add by 1. Order of operations here starting from the square root. So it looks like we're we multiply all our y values by 2. What does that look like? Multiplying a y value by 2 takes us up here, takes us further away here. It looks like we're stretching, pulling away from the x-axis itself. So we can call this a stretch. Stretch away from the x-axis, up and down, multiplying all the y values by 2. The next thing we do to all the y values is we add by 1. That's like a shift up 1. So let's go back to this graph. Now, since we've done the horizontal or x transformations, let's look at the y. Now, for the y, let's multiply by 2. So that means this point would be stretched up here, and likewise, this point double. It looks like we're going to get a new graph up here after we stretch. Now, what do? We got to shift up 1. So we take this graph and we shift it up. We shift it up 1 unit. And it should look the same. It's just shifted up 1. If I can draw it appropriately, hopefully you get the idea, and it starts 1 unit up. So that's the basic idea of how to get what the graph will look like. Now, how to work with specific points. Now, on the original graph, we had a few points marked. In previous videos, we had 0, 0. We had the point 1, 1, and the point 4, 2. How do you get the new points? Well, just follow these operations on the x and these on the y. So for the x, you subtract 1 and multiply by -1. So first subtract them all by 1. So you get -1, you get 0, you get 3. Next, you multiply all of them by -1. Multiply, so 1, 0, -3. Those are the landing final x coordinates. Now let's look at the y's. First, we go through and we multiply all the y values by 2. So we get 0, 2, and 4. Next, we add all those y values by 1. So we get 1, 3, and 5. So on the final graph, we should have these points. The destination of the beginning point, 0, 0, is 1, 1. Hey, that's the destination, the beginning point right there. Okay, that's 1, 1. So we know that coordinate. Now we also have this point right here, x value of 0, y value of 3. Hey, that must be this point. We also have this point, -3, 5. And so we can go over here, and we know we have another point over here, -3, 5. So we've successfully transformed the graph of y equals square root of x according to how we were able to write this equation and then know where final points land on it. Thanks for watching.